This last method for solving systems of equations is using elimination. So elimination is when you use addition or subtraction to eliminate a variable and solve a system of equations. If you think about it, elimination involves eliminate. You are eliminating a variable. When should I use addition to eliminate? So you are going to use addition when the coefficients of the x or the y have the same number but different signs because they're opposite, so we would need to add to eliminate. 5 and negative 5x, when you add those two together, they eliminate to 0. So let's look at this first example here. What I'm looking for is I either want my x value is the same or my y value is the same. Here, we have the same y's. I've got negative 5y and positive 5y. So they are opposites. We're going to add to eliminate. Because when we do negative 5 plus positive 5, they cancel each other out and are 0. So over here, we're going to add everything else. 3x plus 2x is 5x equals negative 16 plus 31, just be really careful with your negatives, equals 15. Then we're going to solve by dividing by 5. We have our x value equals 3. Then I'm going to go back and plug that into either of the original equations. It does not matter which one. So let's say I plug it into the first. Let's do the second one since there's more positives. 2 times our x value of 3 plus 5y equals 31. 2 times 3 is 6. So 6 plus 5y equals 31. Subtract 6. 5y equals 25. Divide by 5, and we get y equals 5. Then remember, when we're writing our answers, we write it as an ordered pair. Our x value is 3. Our y value is 5. So that's our answer. Let's try another one here. Number 2, 2a minus 3b equals negative 11, and a plus 3b equals 8. Here, our b's are the ones that have the same number, 3 and 3. We have negative 3 and positive 3 we would eliminate by adding, because negative 3 plus positive 3 cancels out to 0. Over here, 2a plus a is 3a equals negative 11 plus 8 is negative 3. Divide by 3, we get a equals negative 1. We're going to take that, we're going to plug it into either equation. I'm going to plug it into the bottom one. We've got more positives and a smaller a value. So negative 1 plus 3b equals 8. I'm going to add 1 to both sides. I get 3b equals 9. Divide by 3, we get b equals 3. Remember, we write our answer as an ordered pair. I know we don't have x and y, but we are going to do it alphabetically. So a comma b. So negative 1 comma 3. All right, what about subtraction? When do I use subtraction? It's going to be the opposite of addition, which makes sense. When the coefficients for x and y have the same number and the same sign. So you would have to eliminate by subtracting. A lot of people get mixed up when we have both negatives. So if we had negative 4y and negative 4y, we subtract, because negative 4y minus negative 4, we get that double negative, which really means plus a positive, and those would eliminate to 0. So Looking at number 3, which things are the same? We have our y values here are the same. Positive 2y and positive 2y. We will get rid of it by subtracting because 2y minus 2y cancels out. We are now just left with x's. 5x minus 9x is negative 4x equals 6 minus 22 is negative 16. Divide by negative 4, and we get x equals positive 4. I can plug that back into either equation. I'm going to do the top one. So 5 times our x value of 4 plus 2y equals 6. So 20 plus 2y equals 6. Subtract 20 from both sides. 2y equals negative 14. Divide by 2, and we get y equals negative 7. So our ordered pair is 4, negative 7. Let's try another subtraction one. When I'm looking here, I see that my n's have the same coefficient. We've got negative 4n and negative 4n. If we added, negative 4 plus negative 4 is negative 8. That doesn't eliminate. So we have to subtract. Remembering, negative 4n minus negative 4n. Minus a negative means plus a positive, so we have opposites, negative 4 and positive 4, which equals 0. So our n's cancel out. 2m minus m is m. 6 minus 8 is negative 2. Now we're going to plug that into either equation. I'm going to plug it into the bottom one. So plug in negative 2 for m, minus 4n equals 8. Add 2 to eliminate. I get negative 4n equals 10. Divide by negative 4, and I get n equals negative 2.5, or negative 2.5. So our ordered pair, alphabetically, negative 2, negative 2.5. And the last type is multiplication. So it's not always going to work out nicely that you have the same, you already have the same coefficient. So when you use multiplication is when the coefficients of x or y are different. They don't have that same coefficient. So I've got 2x and 3x, those aren't the same. I've got y and negative 2, those aren't the same. So what we can do is we can multiply so that they have their least common multiple. You can do it many different ways. I always try to find the easiest way. So in this one, I'm actually going to make my y's the same instead of x's, because x's I would have to multiply both equations. But my y's, I technically only need to multiply this top equation by 2 to get it to be the same as the other one. So when you are multiplying, make sure you're distributing that 2 to all values. So 2 times 2x is 4x. 2 times y is 2y. And 5 times 2 is 10. Now we have these two equations, which I'm going to add or subtract to eliminate. I've got negative 2y and positive 2y. They are opposite, so I'm going to add to eliminate. 3x plus 4x is 7x. Negative 2y plus positive 2y cancels out. And 4 plus 10 is 14. Divide by 7, we get x equals 2. Plugging back into either equation to solve for y, I'm going to do it on top since it has a singular y value and we won't have to divide. So 2 times our x value of 2 plus y equals 5. So 4 plus y equals 5. Subtract 4, y equals 1. So our ordered pair is 2, 1. And then the last one. My C's are not the same, 3 and 2. My D's are not the same, 4 and 3. So I have to multiply to either make my C values the same or my D values the same. It does not matter. I'm going to make my C values the same. And I'm just going to highlight on here so you can see which ones I was making the same. So 3 and 2, their least common multiple is 6. So I need to multiply the 3 equation by 2 and the 2 equation by 3. Remember, make sure you're distributed into all 3 parts. 3c times 2 is 6c, plus 40 times 2 is 8d, equals negative 25 times 2 is negative 50. And below, 2c times 3 is 6c, 3d times 3 is 9d, so minus 9d, equals 6 times 3 is 18. Now we can go through our process of adding or subtracting. 6c and 6c, they're the same. We need to subtract to eliminate. 6c minus 6c cancels. 8d minus negative 9d is really plus positive 9d, so that's 17d, equals negative 50 minus 18 is negative 68. We're going to solve by dividing by 17. We get d equals negative 68 divided by 17 is negative 4. We go back and we plug into either equation with the d value of negative 4. So let's do the second one. 2c minus 3 times a d value of negative 4 equals 6. Simplifying, negative 3 times negative 4 is positive 12. So we get 2c plus 12 equals 6. Subtract 12 from both sides. 2c equals negative 6. Divide by 2. And we get c equals negative 3. So our ordered pair, alphabetically, C comes first, so negative 3, and then D, which is negative 4.